Hi, Professor. This is a second video demonstrating the different equations in ER modeling as well as ICU modeling. Let's start from sharing my screen and pour the code into Spider. So uh, we have okay here. So as what we learned from the audience modeling in a given website in the lab requirement. So we have the ER rates for like a each person who was sent in the hospital emergency unit can get out because they are totally cured. But for the ICU rate is only like 40% because some may need to stay in the hospital, some may die, or some may could get out. So it's not 100. It's not 100%. So the requirement is to observe the ER moduling being saturated individually, and the ICU moduling being saturated individually, and both ER and ICU moduling being saturated. And both modules should have at least minimum 3 variables. So in my course, the number of doctor, number of nurse, and number of the hospital beds are the three variable for the ER moduling. And the code is basically familiar with the website given here. Yeah, here. And I have used audience function to plot out. And let me just okay. So this is the plot showing the ER being saturated because as we have 8 patients sending into the hospital, and so in almost 11 hours, not enough emergency units resource could be prepared for all the patients. So and then there's no more doctor or nurse or the emergency bed for the actual patients. But as what we as a like 0 point as like a 80% of the 80% of the emergency room as the number of the patients in the emergency room being sent to the ICU like at a nearly 80%. So if I could just reduce it to like a 40%, and then so it dropped down. Yeah, the red light dropped down because not too many patients being sent to the ICU from the ER. If I keep dropping like a 0.1, the red light should drop. Yeah, almost 0 because too many hospital resources are being prepared for the ICU patients. And let's say if like the pandemic at the beginning of the COVID-19 pandemic, almost 70% patients sent into the ICU. So eventually, I think if it keep going, eventually it reach the saturations, but just not now. Like let's set it as 120 hours for the time interval. Oh yeah, and then we could see. So at almost 85 hours, so both like the emergency units already reached the the full occupation already, but up to 85 hours, the ICU also being saturated because they can handle like not enough doctor or nurse or whatever the resource for the patients. So let's set up the code back. And okay, for the second requirement, the ICU being saturated if I have the patient, like if I have the patient being sent to the ICU directly because like too many traffics or too many traffic incident or too many like probably like earthquakes has occurred, and then we have to time the patient sending sent from outside directly to the ICU, and let's plot out. Okay, and if I set up like there are not many people going to there are not many people going to the ER room, and then so all the people are sending to the ICU. Let's plot down. This is where if I say 6 and 7. Let's see. Something goes. Okay. Let me see. Manage. Oh, maybe 0.1 and 0.2 here. We didn't get to. Okay. So if I have like more 30 people sending to. Something. If I which yeah, and for some reasons, sorry about being so long. For some reasons, I have setting different problem problem parameter to reach the okay. So in this case, we can see if I keep sending more people in, this should this should be faster. No. Okay, there's okay. Sorry about taking time to fix the code because the number of the patients sending to the sending to ICU affect deeply on the differential equation. Like as let me say it's only like a only two people sending in. Okay, let's say we keep everything, we keep the human resource. Okay, let's check on this part and so for 80 people, much changing. If I keep sending more people, we need not changing much. So the only thing is to see if I have yeah. Okay. So in this case, if I have the individuals parameter for the ICU modeling, so I have to time the patient sending to the ICU directly, and then divided by the resource that's ICU units has, and then we can see the ICU being saturated and the emergency uh, department is not. So, but if we change the time interval, oh, it would, I think it would reach to the saturation in some case, like when we get to 120, let's say it's 120, and then we could see the ER department also almost reached to the saturations, and so in this case the second requirement as showing the ICU being saturated is done, and then let's set it back to um let's set it back to the original, and in order to observe both ER and ICU being saturated, and then let's see. So if almost, and I'm fixing the code here to see if we could make out the saturation case for both. We need some time to set it up. I may need to go all the way back. Okay. This is the original. If I have 3050 bed for the ICU, if I okay, there's too many patients be sending in the, okay, there is. So in this case, sorry about it taking so long to set up the parameter. So in this case, if I have a extra patient sending directly to the ICU department, and as well I have the patient sending to the ER department, then transferring the patient from the ER department to the ICU department, and then we could see like in almost 7 hours it reached to the set so both department reached the saturations like 7 hours. So the ER is being set raised already, and it's too fast. Let's set it not that many people. Okay. If I change negative base, yeah, basically close. So in this case, we could plot both EI and ICU being separations. And so I have proved a minimum of three variables. Oh yeah. So for the ICU department, I mean ICU moduling, I have actual specialized machine for keeping the patients in reality needs. So that's the fourth variable, and I have to prove the minimum three variable for both modeling. And I see you in the next video.